Okay, hello, welcome back. It's been a while. Can you can any of you turn on the video? Thanks. Thank you. All right. Okay, let's begin. Okay, welcome back. So it's been a while. It's been a few weeks, several weeks, right? Since our last lecture. So in today's lecture, what we'll be talking about is the makefile. So by the way, if you have any, this lecture is based on this book. It refers to this book. So all the examples and example codes are from this book actually. So, and this is the link, by the way. If you click it, you'll be able to go to, this book is available online. So mostly on chapter 2, I think, yeah, if I remember correctly. So please refer to this book if you need more information. All right. Okay, so beginning from not the definition. So what is a makefile? So you probably have some experience with makefile, right? At least you've seen one before, and at least hopefully you have a chance to open it as well. So it's a file, as the name indicates, it's a file that helps
Professor,
to. Oops.
the screen isn't shared.
Oh, sure. Sorry. Okay. Thanks for letting me know. Okay. Okay. I wasn't checking the chat. Okay. All right. So you can all see my file, right? See my slide, right? So again, this is the book. So this is the book that we are referring to. Okay. And this is a link. So you can click it. You'll be able to access the book. Okay. All right, so what is a makefile? It's a file that helps to decide which parts of a large program needs to be compiled. So what this means is that suppose you have, suppose you're building a word processor with 10,000 source code files. Then every time that you change one file without make, you have to recompile everything, right? Meaning you have to recompile 10,000 files every time you change one line of a code, right? That's very, very inefficient. And the makefile is to avoid this. Okay. So how do we do it? We build a makefile, which is basically a bunch of configuration for a partial build. So partial build, when I say partial build, what this means is that we only want to compile a part of the code. We only want to recompile only the part of the code that was changed. Okay. Not only maybe let me make it more clear. So not only the parts that was changed, but also the parts that was dependent on what was changed. Okay. So if code is dependent, a piece of code is dependent on another piece of code, right? So if A, oh sorry, if B, oh sorry, let me say, let me put it this way: if your code A is dependent on B, right? And B is updated, if the B is updated, then of course B should be recompiled since it's updated. And also the A needs to be recompiled. Okay, so you have to keep that in mind, right? So this is called the dependency graph, but we'll not talk about too much about, we'll not talk about dependency graph in this lecture, but you need to get the idea that files can be dependent on one another, right? So whenever you have you change a file, and there's another file that is dependent on that file, that the dependent file has to be recompiled as well. Okay, let's keep that in mind. I think that will be more clear. How we achieve that will be more clarified as we move on. Okay. All right, so we don't want to recompile all of the files if you just edit one line, right? So we basically want to recompile only the files that has changed and also the files, dependent files, right? So make is a tool to enable this task. Basically, how do you use the make file is you just type make, assuming that you have a make file in the same directory, then all the compilation will be done for you. Okay, and in this lecture, we'll understand how the make is written, right? And also for your homework, will be on building your own make file. All right. So this class is a brief introduction to make and makefile, right? So make is the is the so make is a command to run the makefile, and makefile is the name of the file. Okay. Okay. Although not cover the entire parts of the makefile, we'll basically cover the basics. But hopefully this will be enough. We think this will be enough to cover all your projects in KAIST, right? And at the time, if you need more if you ever become a real professional, then you'll learn it on your own when you get there. Okay. With these basics, I think you'll be ready to dive into professional level in the future. Okay. Let's look at make and makefile. Okay. So make executes rules in makefile. Okay. Makefile can be, so this is the name of the file, makefile. Okay. And this makefile can be named under different names. Okay. You can also use makefile with the uppercase, and you can also have the name GNU makefile. Okay. So if you type make, right, this utility will execute makefile, right? Well, let's not say execute, because makefile is not an executable, right? This is just a bunch of rules that make will interpret, right, and execute, right? And this can have different names. And this is the makefile content here. Okay, we're starting from the very basic one. So this is the makefile content, and this is how you should look at it. Okay, so hello is the okay, hello is the this weird. Can you just give me 1 minute? I think I'm feeling bad again, so I thought I was okay. Let me just take a rest for 1 minute. Okay, sorry. Okay, thanks for waiting. I'll try again. I'll try to speak. I'll try to speak lower. Maybe that's easier. And I'll try to talk slower. Okay. Okay. So thanks for waiting. So let me resume. So hello is the target. So hello is the target. So basically, this is the file to make. So we basically want to generate hello file here. Okay. And the prerequisite is what follows after the colon. Okay. Okay, so basically, so what follows the prerequisite is a hello.c here. Can you all hear me? Is that okay? Okay. Prerequisite is the hello.c here. Basically, prerequisite is so what this means is that target is dependent on the prerequisites. Okay. So this basically indicates the dependency graph. Okay. So target is dependent on prerequisites. All right. So what this means is that whenever the prerequisites change, target needs to be recompiled. How do we recompile it? Is the command. So how do we compile? We recompile using this command here. Okay, that's what it says. So again, at the high level, what this means is that whenever any prerequisites change, since the target is dependent on prerequisites, we have to recompile the target. Okay, and how do we compile it? Is using the command. Okay. Okay, so how do you do it? How do you how do we run this? Is make hello. We run make with followed by hello as an argument, and this argument will actually tells the make utility to find the corresponding target. Okay, and execute execute the command following, and not execute the command. So let me repeat. Okay. So if you do make hello, the make utility will look for the corresponding target in the make file and do whatever is followed. The rules follow the rules instructed in the make file. Okay. If you just run, so basically we will run this one, right? So what if you just run with run make without any file, without any argument, then it will just run the first target. Okay. So what I'm trying to say here is that the make file can have multiple targets, right? It can have multiples of these. So in case if you just run make without any argument, it will just run the first one. Okay. And one way to understand this is this. So as I just told you, target will be rebuilt, recompiled when the prerequisites, meaning the files that the target is dependent on is newer, right? Is when the prerequisites change, you need to update the target, right? You need to recompile the target. That's what I just said. Then how do we know if it's changed, right? We basically look at the date and time when the prerequisites have changed, right? And by looking at if any of the prerequisites is newer than the target, that means target has to be recompiled, right? So basically, so then it runs this command. What if the target is newer than all the prerequisites? Then makefile does not do anything. It just says the file is new. Is already up to date, so you don't have to recompile, right? Okay, so makefile basically contains a set of rules to build an application, right? You can have multiple rules in one file, as I just said, right? And each rule can have multiple dependencies, meaning prerequisites can include multiple files. Okay. And the default rule is the first rule in makefile. This is the one that is executed if you just run make without any argument, right? And so a rule consists of target, prerequisites. It can have many, and the tabs, and the command. And the command should be preceded by a tab. Okay. Okay. Let's look at another example of the of the rules in makefile, right? So suppose you want to build a file foo. Then it needs these object files as well as header file, and this is what you want to run to generate file foo. Okay, and okay. Okay. So I think I feel I think I need to ask for your understanding. I think I need kind of I think I kind of feel bad when I look down. So I try not to look down, meaning that I might be writing less on the tablet today. So hopefully you understand that. Okay. I think I feel much better when I look up into the monitor. So I'll keep myself there. Okay. All right. I'll use the mouse instead. Okay. So here, of course, the target is foo, and the prerequisites are these, right? As we said, these have the foo has 3 prerequisites, right? So if any one of them change, I mean, after the last time the foo was generated, then the next time when you do make foo, then it will recompile foo, right? And the command is this. So how do we evaluate the rule? How do we evaluate the rule? It first finds the prerequisites and the target. If the prerequisites have associated files, we evaluate them recursively. What this means is that we might have this, for instance, libfoo. We might have another rule for libfoo, right? Later on in this packet, right? Right. So the make utility, what make utility will do is it will look at each of the prerequisites and see if there are rules for each of the prerequisites, right? So what this means is that one file is dependent on another file, and that file can be dependent on another file, right? Right? Of course, there can be many, right? So we basically have to check everything. And in order to generate A, we have to make first, let's look at oh, I forgot not to look down. Okay. Let me let's look at this one. Then what we have to do is we need to generate we have to generate, because of the dependency, we have to generate C and E first, right? So we basically run the rules for C and E first, and then from there we generate B, and then in other words, we run a rule for B, and then D, and then finally A. Okay, right? Oh, this is an example. This example actually has foo.o. Yeah. So suppose we have found another rule for foo later on in the file, then we have to generate it. Then we have to compile foo first, right? Foo.o first. Of course, assuming that foo.o is outdated, right? If it's updated is up to date, you don't have to recompile, of course, right? This is what it's saying. Okay. So if any commands fails, building the target terminates and make exits. So make will spit out an error saying spit out an error and then terminate, and you'll terminate. Okay. Let's look at an example for evaluating rules here. Let's look at this one here. By the way, this example is also from the book that I've mentioned earlier. So Flex here is a lexical analyzer tool that translates a lex source, which has a .l file into C source code. So don't worry about it. So this is not the main part of this code, part of this lecture. So don't worry too much about it. At this point, if you don't know about it, don't worry about it. You only have to understand that for this lecture is that this is just some tool that has L file, which can be translated into C code using Flex utility. Okay, so just accept that. The reason why we have it here is because this example is from that book. Okay. All right. So, but this is not the point of this lecture. Okay. But anyway, so you want to generate count underscore words. And then you first run into count words.o. Then count words.o turns out that it is also dependent on, so it has a rule. We have a rule for counts words.o, where this is dependent on count word.c. And then we have to run this first. And then it looks at the next one. It looks at the lexer O, and it turns out, okay, it looks at lexer O, and it turns out we have a rule for lexer O, which is dependent on lexer C, right? Lexer.c, and it turns out, and we have a rule showing that lexer C is dependent on lexer L, right? So where the lexer C can be generated from lexer L by using this command. Okay, don't worry about what this command indicates. Okay, it just accept that this command just changes .l file to .c file. Then we are able to generate .c file, and from lexer.c we'll be able to generate lexer.o file, right? Okay, and then we're done. So we've updated lexer.o file, right? Okay. Of course, this is just a library, as we all know. Okay, this is what it's saying. So I'll try not to look down. So basically we're maybe not. This is okay. I think you understand this, right? If you don't, just let me know. I'll try to explain in words as opposed to writing it down. Okay. Okay. So a few tips on the rules. A rule can have multiple targets, right? As you can see here. So as you can see here, until now we've only talked about having one target, right? However, it turns out you can have multiple targets. right? So this is exactly the same as this. Okay, so you basically don't have to write 2 lines and just merge it into 1 line with multiple targets. If the multiple targets have the same dependency, okay, or prerequisites. Not all prerequisites need to be defined all at once. You can basically you can cut it down to multiple rules. Okay, multiple rules. Okay, so if a file has all these dependencies, you can just write it into multiple lines. Okay, all right. And how to write? There are also something called wildcards and variables, and so these are some of the wildcards that is actually is exactly the same as the wildcard that you use in Bourne shell, B shell. But anyway, so asterisk, as we all know, is all the file names in the current directory, right? Which is consistent to your knowledge when you're using the shell, right? And if you put, similarly, if you put wildcard.c is all .c files in the current directory, right? And tilde is just a home directory. And you can also define variables in the makefile, okay? So how you do it is the format is like this: variable name equals a value. So variable name equal a value. Okay, so you can basically generate CC, a variable called CC that you will be using for you to use in Makefile. And then when you want to use the value that is stored in CC, not stored, it's just a preprocessor, right? You do it like this, okay? What this means is that this will be replaced by GCC when you actually run it, okay? So these are similar things here. Right. This actually indicates a file name that represents the target. So the target is this, right? So this will be replaced here. Okay. And this indicates the file name of all the prerequisites. So all the prerequisites are all .c files here, right? And this will be all replaced here. Okay. So basically, why do we need this? In order to make our lives easier, right? When you're writing a makefile, you don't want to write all the files, right? Every time. So these are the rules. These are not the rules. These are the some of the ways for you to make it easier. Make writing a file easy. Make file easier. And this is basically, if you look up all the variables, it actually turns out to be this. And this is practicing wildcards. Okay, so if you do this, this actually means the same as this, right? And try to map it with these here, okay? Then you'll be able to understand everything here, okay? All right, try to map it. Okay, again, don't be fooled by flex here. This is not what is important in this lecture, okay? Just accept that the flex is a utility to translate L file to C file, okay? Okay, and this is how you translate it, right? Okay, pretty simple. And now let's move on to the case where we have files in different directories, okay? And suppose the .h files is under the directory, under include, and C files and L files are under source. And you have a home directory for your file, for your project, and makefile is under this directory. Okay, you probably have seen a lot of this structure before, right? In real programs. right? Not the program, probably not the program that you wrote by yourself since it's small enough. But if you look at other, programs that you download, then you can actually see that it has many folders underneath, right? In those cases, how do we need a way to tell the makefile which folder to look into, right? Just like when we run GCC, right? And we have to tell where the library is, where everything's are, right? Where header is, and so on and so forth, right? Same here. You have to tell the makefile to know to find to tell the you have to tell the makefile which folder to look into. Okay. So one way to do it is like this: include. So all the header files are included under include folder. Then you just put include here. Okay. To tell you basically explicitly indicates the full path from this directory to the header files, right? This is what they did here. Okay, will this work? No. And this will spit out an error saying there's no rule to make a target count_word.c, because count_word.c is under the folder source. However, this is not indicated, right? So the problem becomes how do you do this? Okay. Of course, we can just put source here, and this will work, right? But we don't want to do this, right? We're trying to look for a better way to do this, right? Is doing this. You can basically put vpath. You can set up another not an option. It's a let's say preprocessor of makefile to look at the source file. Okay, so by putting this, the make utility, what make utility will do is that whenever it cannot find any file under the current directory, it will look into this folder as well. Okay. All right. So basically, you can do this. Another way of doing this is actually just passing the preprocessor options to the C. Okay. Right. Again, you probably have experience in programming that you probably have learned by now that a lot of answers that we teach here, there are a lot of ways to achieve the same goal, right? We have seen that over and over, right? Here, same here, right? Of course, you can put source, right, and include like this, but this is probably not a smartest way to do it. A better way would be like putting vpath of source. Okay. Another way is using C flags as well. But here, CPP flags is the CPP flags. Let me put it this way. Okay. Let me put it this way. Yeah. Let me repeat here. Maybe I can make this more clearer. Okay. One way to tell one way to address this issue, address the directory issue, is to put vpath so that the make utility knows where to look into, right? And also another way is to actually put a flag within the GCC, because there are ways for us, as we know, there are ways for us to indicate the directory as a flag for GCC, right? So we can actually we can actually put the GCC flag as a variable, so that this is put into GCC command, right? So here we put an include option, include flag CPP flag for include to indicates the header locations as a flag of GCC. Does it make sense? Can you see the difference between the two? Okay, so so that's what I'm saying. And another thing you might be, if you're familiar with the C flags, right? C flag is C compiler. You might be confused between these two. There's another GCC flag called C flags. This is actually for C compiler options. And CPP flag is actually an option for like C++ and C. So you, I have an example of this. Not an example. I have a better explanation to explain the difference between these two later in the slides. So I'll get more I'll talk more about this on that slide. For now, let's just understand these two, the difference between VPath and VPP path, VPP flags, right? One, VPath is to let using the functionality of make utility, right? And CPP flag is basically just using a variable function in the make utility, and to put a flag into the GCC command so that the GCC can compile correctly. All right. So VPath is telling the make utility to find the file by self, right? And CPP flag is actually passing the variable as a GCC flag and let the GCC find it, right? So you see the difference. Of course, there are other ways to do it. We can use VPath as opposed to using CPP flags here. One way to do it is, well, you can put these three lines. What this line is doing is that any file, by the way, any file with this .c extension is under source folder, and any file with .l extension is under source folder, and any file under h extension is under include. Okay, this is what it's saying. So if you do this, you won't need CPP flag anymore, right? Because it's already shown here. It will be already taken care of by the make utility. One more thing to note here is that the percent notation here indicates any file name. Okay, so any file name, any file with .c extension, any file with .l extension, any file with .h extension. It's what it's saying. Okay. Okay, let's move on. So let me just give me a few seconds. Let me take a rest a bit. Okay, let me resume. So there's something called phony targets. Phony target is a target that does not represent the file. Okay, as we can see until now, all the targets were actually the name of the file, right? It could be .o file, it could be some executable, it could be some O file, could be .c file or anything, but they are all commonly file, right? File names. But there are cases where when you don't want it don't want the target to be a file, like clean. This is a very typical target that is used by that is used without that is used okay. And what this is doing is that if you run make clean, it always executes this. So why do we use, I need to first tell you why we need this. So if you type make clean, then all the files, .o files or whatever files that you generated in between are executed, are removed. So you run this when you compile everything from the beginning. So suppose you're a programmer, right? And you want to just clean everything and run everything from the beginning. Then if you don't run make clean, and then if you don't have make clean, then some file might be updated, some file may not be updated, right? And so, meaning that depending on the updated status, some files may be compiled and some file may not be compiled, right? And there are cases that you don't want that. There are cases that you want to clean everything up and then beginning from the start, right? Basically, you want to compile all the 10,000 files in the word processor. There are cases like that, right? If you want to do that, you run make clean. So basically, you remove all the files in the all the files that is currently left, except the source files, right? You remove everything except the source files, so that .c files or .h files or .l files, right? So you move everything that it was generated while compiling, so that you begin from a fresh start. You do a fresh start. And that's why a lot of people use make clean. Okay, so make clean is very essential. It's very widely used. And how is this done? Is like this, right? It's just to move everything, right? And you can actually see that the clean is not a name of a file name, right? It's not a file name, right? These are called phony targets because the target is not a file name. Okay, so if you make clean and everything is so if suppose if you just do this, the make sort, if you just sorry. Suppose if you just do this, then the make utility will be confused because this is supposed to have file name, right? So what makefile would do is it will look for the file called clean, right? So if you just do make clean, the clean, it will just say clean is up to date because there's nothing dependency, right? This is a file. If you by default, the make utility will interpret this as a file name, right? And there's no dependency. Therefore, the make will just say clean is up to date. So you basically have to tell the make utility that this is actually a phony target. It's actually not the name of the file, right? So how do you do it? You just put this in the very beginning of the make file to tell the make utility that clean is actually a phony target. You can have similarly, you can have many different people typically have many phony targets, and you can look through them yourselves. Okay, and let's move on. So another one is the pattern rules. So the pattern rule is basically some rules that you don't have to write. So these are implicit. Oops. These are implicit, meaning these are defined by default by the make utility. So even if you just do this, So you can actually see that there are no rules here, right? But this still works because there's implicit pattern rules that is given by make utility, that is assumed by utility, right? So these are built-in rules, and the pattern rules use the stem of the file as expressed as %. We've talked about this before, right? This is the name of the file before the extension, right? If you say %.c, this indicates any file with C extension, .c extension, right? And this is called the stem. Okay. And with this, and these are the implicit rules here. Okay. Well, let me just move on to the next slide. I think that's better here. Oh, it's the same slide. Let me just erase everything first. Kind of messy. Okay. All right. So so this here, since it does not have a rule, it will just use implicit rule here, which is this. Well, this is matched with this because it says, okay, it only has a stem, right? Target only has a stem, okay? It only has a stem without any extensions. Okay, so it matches, and the dependency has .o. Okay, then it will just run this, where these are given by default. Of course, you can change it, right? But we have default values. So this is what it will do. So the first target is expanded by this. And count words is like this. So by the way, another thing to note here is that we do not have count words. Sorry for the terrible writing. .o. We don't have it here, right? But because of this expansion rule, it will expand to this, right? It expands. Maybe my previous explanation was bad. Okay, so it will look at the target without only the stem, right? It finds there, and then it expand to this. So it will expand this to this, right? Does that make sense? Right? It means the same stem with .o, right? The same stem, count.words, count_words, .o, right? So this will be expanded to this, all right? And the rest of them are already there, so it just follows, right? And the next target is count_words.o, right? Then it will look at this rule here, and it will be extended. Similarly, it will be extended to this here, right? Okay. And it also has count.h here. Yeah. I think this should have lexer.h here as well. It's just okay. And source count words exist, and it does not have a prerequisite, so it just runs a command and moves on. Okay. All right. Okay. Let's look at a little bit more. So next target is counter.o, and this will be expanded This matches with this rule here, this target here, and this will be expanded like this, right? As you can see here. And Lexer H will be also expanded corresponding to this. Oops, not this. Oh, wait a minute. That's a bad explanation. Okay, next target is Lexer.O, this one here, and where the Lexer.C, source Lexer.C, so as you can see here, it tries to expand Lexer.O to Lexer.C, right? Using this rule here. However, turns out Lexer.C does not exist. Then what does it do? It triggers the next rule of this. It triggers another rule of this. So it's .c will be generated from .l. Then it actually finds that so it expands to this rule here, and then then it turns out we find Lexer.l, right? Lexer.l exists, therefore it will run this command. Okay, does that make sense? So again, what this is saying is that, okay, so if this is Lexer.o is expanded to this by this pattern rule. However, Lexer.c does not exist. In that case, it will look for another rule. The make utility will look for another rule, and this which is this rule here, and it turns out .l exists. Therefore, the makefile will make utility will actually generate .c from .l using this rule here. Okay, meaning it will generate this rule by itself. Okay, to build Lexer.c, and then from there it will generate Lexer.o. Does that make sense? So make utility is quite smart. Okay, and so you can also have many different variables and built-in rules. Okay, you can change all those variables here, right? These are all the variables that you can change by yourself. By the way, compile is defined to be this way, right? So basically, this is the compile option, default compile option given to the GCC. One thing to note here is the C flag. Is a C flag and CPP flag. Okay. As we talked about in previous slide, I told you that the CPP flag is preprocessor options, which applies to C++ and C. And C flag is just for C. Okay, as you can see here. As you can see here, we have C flag, which is for C, and C++ flags, which applies both for C and C++. Okay, so what it's saying is both C flags, we're looking at C right now. We're learning C right now. So therefore, we have both C flags and CPP flags as a default when you're running GCC. So basically, if you're assuming C, it doesn't matter if we change this to C flag, right? Okay, I just wanted to let you know about it. Sorry for the terrible writing, but hopefully you understand. Okay, so this C flag will not be there for C++. Okay, so if you want to write a makefile that applies to both, and you want to have a flag that applies to both C++ and C, then you need to define it as a CPP flag. Okay, that's the difference here. Let's look at a practice. Let's do a practice in writing writing a makefile. Okay, so if you want to build a program K, okay, and if you have 3 files that consist the program K, and file A includes 2 header files, file C and B includes each header file. Okay, and all files can be modified at any time. Let's write a reasonable makefile, which would be this. Okay, it's just not a. I wouldn't say this is a reasonable, but this is the most naive way of writing a makefile, right? So make all. If you just type make on a prompt, and assuming that this is the first and only rule, then we'll just run this, right? Which is the same, probably the same as what you would do on your when you compile yourself on a command prompt, right? Well, this problem has there's no prerequisites, so it will compile every time. So it does not have any prerequisites, meaning it does not check for the updates, right? So just run this every time. Okay. Then you write another version. So let's just add all the files into prerequisites. Then would this solve the issue? Not really. It will recompile every file if any prerequisites are modified, right? Well, it's better than this. So this one is better than this because it will not compile if all the files have not changed, right? However, if any of them has changed, it will recompile every file, right? That's not good. So version 3 is actually a reasonable version. So if you do this, so it clearly shows the dependency of different files, right? So the object files here is this. So the executable is dependent on these 3 object files, right? Where each of the object files are dependent on its header. So by doing so, we enable partial and incremental build, which was basically the goal of making a makefile, right? So if we started off from saying that, okay, if we have 10K files, we don't want to recompile all the files, right? Every time. So we need to do makefile actually lets us to do incremental rebuild, right? Incremental and partial rebuild. And this is actually done. So suppose if .h was if a2.h was changed, then only the file A will be recompiled, and these will not be recompiled, right? Of course, the executable has to be recompiled because the executable is dependent on .o, right? File A.o. And it properly uses built-in pattern rules, right? It uses all the rules here. It does not have any rules here, so it uses the built-in rules, right? And also it properly uses C flags of WALL and WError, right? WALL and WError. So CC is a GCC. We're using basically GCC here, and options will be C flags will be the flags that will be used here, right? By the GCC, right? By the GCC, right? So so it's printing everything. So it uses WALL and WError, which are the options. Basically, are the options that we use on GCC 209, right? Okay, so the homework, that was it for today's class. And the assignment is due next, of course, as always, it's due on next Friday by 11:55. Okay, and this is actually to generate your own makefile for your homework 3. assignment 3 for 209. So if you're not taking 209, please take a look and just follow this instruction here. Okay. All right. Any questions? All right. That's it for today. So you're free to leave, and I'll be here. I'll be here for the next 1 or 2 minutes. I don't feel too good, so please excuse me. You're free to go. Yeah, there's one question. Slide 12, you see flags. Slide 12. Okay. Oh, okay. What do you use? See flags. Oh, okay, that's right. Oh yeah, that's true. That's true. When the question was, shouldn't it be okay to not use this because we have C flags already? Yeah, that's true. Thanks for that's a good catch. I think this was just a there was one question about the assignment 3. So can you please post this on the on this is something that I should not answer right at this moment because this is I think this needs to be shared among TAs and the professors. So can you please post this on on CampusWire? Thanks. Okay, thank you. Okay, thanks for listening. Maybe I think I need to go. Yeah, I don't feel too good, so let me take a rest. Thank you for listening. If you have any questions, please post on CampusWire. Thank you. Have a good weekend.